Welcome back, Chemistry 30. So this is the part 2 video of the ionic bonding section, the 8.2. So if you turn to page 295, we'll look at these examples on the bottom here. So if we take a look here, it says, what is the ion, predict the ion generally formed from strontium, sulfur, and aluminum. Now, of course, you have your pink tables there. You kind of have an idea as to what type of ion they form. But if we just simply look at the periodic table, strontium, for example, Sr. Here's strontium right here. Group 2, and of course that tells you if it's group 2A, it has 2 valence electrons. And of course to gain an octet, so it has 2 electrons already, is it easier to lose 2 or gain 6 to get 8? And of course lose 2. So it's going to likely form a 2 plus ion. Okay. If we look at sulfur, S, take a look where sulfur is, there it is right there. And it's, of course, it's group 6A, so it has 6 electrons in its outer level. So it's either going to gain 2 or lose 6. Hey, it's easier to gain 2 to have the same electron configuration as argon. So it has 6, it's going to gain 2 electrons, so it's going to have -2 as a charge. And lastly, aluminum. If you look at where aluminum is on the chart, group 3A, 3 electrons, so it's either going to gain 5 or lose 3. Losing 3, so it can become like neon. Okay, so if we take a look, that's simply how you could analyze that, just simply looking at a periodic table, seeing what group they're in. And for now, we're just going to look at the group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and of course the 8A, the noble gases themselves. So to recap, strontium, of course, was in group 2A, so it has 2 electrons. Easier to lose those 2 than gain 6 to get 8, so Sr2 plus. Sulfur, as I mentioned, it was a group 6A, so to get 8 in its electron, or in its outer level, gain 2 electrons, so it's S2 minus because it gained 2. Aluminum, it's in 3A, easier to lose 3 than gain 5 to achieve that octet number of 8, so Al3 plus. Easy stuff. And lastly, in the next page here, the ionic charges we predicted here are confirmed in tables 2.4, 2.5, yes. Predict the charges on the ions formed when magnesium reacts with nitrogen. So magnesium, group 2, so it's going to lose those 2, so be 2 positive. If you lose 2 negatives, you become more positive, so 2 plus. And the other atom here, nitrogen, it's group 5, so it's easier to gain 3 than it is to lose 5, so it's gaining 3, that means its charge is going to be -3. And of course that's what's illustrated here. Magnesium is 2 plus, nitride is 3 minus. Transition metals, we're going to look at those likely later. Because ionization energies increase rapidly for successive electrons removed, the lattice energies in ionic compounds are generally large enough to compensate for the loss of up to only 3 electrons from atoms. Thus we find cations with charges of 1 plus, 2 plus, 3 plus in ionic compounds. Most transition metals have more than 3 electrons beyond a noble gas core, so of course there's different amounts. The octet rule, although useful, is clearly limited, especially if we're looking at the transition metals. But for now, we're only going to be looking at the general rule of the representative groups, the A groups, that whatever group they're in, that's how many valence electrons they have, and then from there we can figure out exactly how many are gained or lost to achieve a state like those of the noble gases. Alright, so just to bring this home now, thus in forming ions, transition metals lose the valence shell's electrons first, then many D level electrons, if you've taken electron configurations before, that happens next. Alright, so I think we'll stop there. So that is the material we need for section 8.2, looking at ionic bonding, of course the transfer of electrons there, and then writing the Lewis structures there. For a positive ion, just simply have the positive amount, no dots. The positive means that it's going to be the noble gas that's directly behind it. Or if we're looking at calcium, it's 2 behind it. And those are the nonmetals. The nonmetal atoms, when they gain, they get a full level in square brackets with 1 negative or 2 negative or 3 negatives, depending upon how many it gained. All right, see you again.